Okay, so now, example 2, we are going to find the tangent and normal lines to the equation x squared minus xy plus y squared equals 7 at the point negative 1, 2. So we're going to do the same thing, but it becomes a little more involved with this type of equation. So let's at least first of all take this off. It should not be there. Alright, so we're going to take the derivative with respect to x to both sides. Okay, so the derivative with respect to x of a constant is 0. And then we have a couple things that we have to do here. We need to use actually product rule on this. Okay, so the derivative of x squared is just 2x. And then I'm going to write minus, because there's subtraction there, and I'm going to do my product rule in parentheses. Might run out a little room there. So this is the first thing is the x, and the second thing is the y. So first d second, and remember we already have the subtraction sign there, is x. The derivative of y with respect to y would be 1, but I still have to have the dy dx in there. Plus second d first would be y times the derivative of x, which is just 1, and we don't need to write the dx dx because dx dx is just 1. Okay, so right in here is our product rule. First d second plus second d first. And then finally the derivative of y squared is 2y dy dx. Okay, sorry that I had to squeeze that all in there. Now we're going to do the process of, we have to get these dy dx terms together. So first I'm going to distribute this negative sign. So I have 2x minus x dy dx minus y, distribute that, plus 2y dy dx equals 0. Okay, so what I'm going to first do is, these terms are linked with the dy dx because of the multiplication sign, so I'm going to leave those on the left side, but I'm going to move to the other side these other things. So what I'm left with now on this side is negative x dy dx plus 2y dy dx. Those are my dy dx terms. And on the right side, if I move the 2x and the negative y over, what I have is negative 2x plus y. Okay. So I essentially factor a dy dx out of both terms here, and I'm left with negative x plus 2y. And then, because I'm running out of the room, I'll add this up here. But what I'm going to do then is divide both sides to solve for dy dx. So what I have is that dy dx equals negative 2x plus y over negative x plus 2y. Okay. So the tangent line then would be at the point negative 1, 2. We have a little bit of work to do. So to find my slope, or my m, I plug negative 1 in for x and 2 in for y. So I have negative 2 times negative 1 plus 2 on top. And then the opposite of negative 1, which would be just 1, plus 2 times 2 on the bottom. So that gives us 2 plus 2, which is 4, and 1 plus 4, which is 5. So in this case, our slope would be at 4/5 for our tangent line and negative 5/4 for our normal line. So y minus 2 equals 4/5 x plus 1 is my tangent. And y minus 2 equals negative 5/4 x plus 1 is my normal. Okay. And keep in mind, when we have this, the reason this is called implicit differentiation is because these are not functions. These are implicitly defined. So the last example we saw, a circle, and these would just be some kind of curves that possibly would fail the vertical line test.